everyone. Uh, Topic is on fundamentals of IoT. Continuation part from the first video. The introduction part, like introduction to this IoT. Okay. So this is the outline where we were discussing about. We have completed this definition of IoT, characteristics of IoT, and physical design of IoT. Now we are going to see the block diagram of IoT. Okay. So this is the block diagram of IoT, where we are having connectivity, processor, audio video interfaces, memory interfaces, graphics, storage interfaces, and IO interfaces for sensors and actuators. An IoT device may consist of several interfaces for connections to other devices. Either of it may be a wired or it's wireless connection. Yeah. An IoT devices may consist of several interfaces. Okay, it might have several interfaces for connections to other devices. Either it can be a wired or wireless. So many IoT interfaces like IO interfaces for connectivity interfaces, memory and storage interfaces, audio or video interfaces. Okay. IoT protocol. As we know that TCP/IP protocol and ISO model, according to that, we have certain layers, right? The first layer is data link layer, the next network layer, transport layer, and application layer. So when you talk about this layer, link layer, either the links, the connection might happen by using any of these features, like it might be an Ethernet, Wi-Fi or WiMAX or LR-WIPN or 2G, 3G, 4G, 5G, like so on. Any connectivity, any network, any internet connection through this data link layer. Okay. Then coming to the next layer is network layer. Here we are going to use IPv4 or IPv6 or 6 low PAN. Any of these like any of the internet protocol can be used. It can be a version 4 or it can be a version 6. Okay. So nowadays, in most of the users, in most of the cases, we are using IPv6. Okay. Well, moving on to the next layer called transport layer. Here we are having two layers. What is that? TCP layer and UDP layer, UDP protocol. Okay, TCP protocol is what? Transmission control protocol. UDP is UDP datagram control datagram protocol. Like these two are the transport layers, which is main for, or which is responsible for transmitting the data from one end to the other end, which is from source to the destination. So while transferring the data, there should not be a packet loss or the data loss should happen. So for that, what the method they follow is they divide the data into some equal parts, and then they'll transfer transfer the data in terms of packets, so that there would be no loss of packet during transmission. So suppose for example, there might suppose there is a packet loss during transmission, then the source will get an acknowledgement saying so and so packet is missing. So again now, source will understand that, okay, so and so some particular what do you say? Some particular packet is missing. So now the transport layer is responsible to transfer that particular packet back to its destination. So all these responsibilities, all these duties are done by this under this transport layer. It can be a TCP or it can be a UDP layer. So coming to this application layer, HTTP, COAP, and WebSocket, MQTT, XMPP, and GSS, all these are different transfer protocols. HTTP transfer call is what? Hypertext transfer protocol. When we talk about COAP, it is a constrained application protocol, WebSockets, message queuing, telemetry, transport. Another one is XMPP, Extensible Messaging and Presence Protocol, DDS, and AMQP, that is Advanced Message Queuing Protocol. These are different protocols that are used to transfer the data in a application layer. Application, like if you have a, suppose we are using a mobile phone, we'll install so many applications, right? Now that layer, the part, the application which you're visually able to see, all this transport network, data link layer, all these things happen at the back end of your application layer. So now the application which is that you can visually see whatever you want to do, and you can operate which thing you want to have, which data you want to transfer. Everything comes under this application layer. Under this transport layer, network layer, and the data link layer is connected. Okay, this is what about the IoT protocols. Now moving on to this next topic, logical design of IoT. Okay, logical design of an IoT system refers to an abstract representation of the entities and the processing without going into the low-level specifications. Okay, so here if you can see logical design of IoT, we are having application, sensor, like services, communication, security, management, and device. These are all the different design elements designed in such a way that what the basic things that we are required. See, first we want an application. Okay, application should be managed. It should provide some services. That application should be able to communicate with other devices, and that application should, like, the device should have some security, and finally you need a device to have this application. This is what the logical design of IoT. An IoT system comprises a number of functional blocks that provide the system the capabilities for identification, sensing, actuation, communication, and management. All these comes into IoT system comprises. So before we move on to this, like, we'll have small example. Okay, we'll just see what a simple example related to this topic. Okay. This is a technology roadmap, which means, see the drastic growth, like the growth of the technology from 2002, from 2000 to 2020. This is the growth. What is the growth that we could able to see? See, before around the 2000 and all, in those days we used to have RFID, radio frequency identification. Okay, radio frequency identification tags for facilitating routes, the routing, inventory, and loss prevention. In those days, like in 2000, the radio frequency identification, like if you use a radio channel to the particular area, it might not reach the signals. Radio frequency. So that is the case in 2000, and the next level is a vertical market applications, where here the security, healthcare, transport, food safety, all these points are taken into the consideration, and they have developed for cost reduction, leading to diffusion into second wave of application. This phase we are calling it a second phase, second wave. Okay. Then coming to the next part, next growth, the next step that we have to come is locating people and everyday objects. See, locating people, any object or any person moving from one place to the other, we can locate them where they are. Google Maps. Okay, you can have use a sensor and connect to that person, or insert that person to like button or like on bag or anything. If you put on this locating like what is that sensor, in that case the wherever the person or the wherever the people are moving, the data is going to be stored. So in so location and where he's now, everything can be registered. Okay. Later on, we came up with the physical world web, teleoperations and telepresence. In that, ability to monitor and control distant objects, software agents and advanced info sensor fusion. There is a roadmap. We call it as a technology roadmap of an IoT. Starts from RFID and it's drawn to teleoperation and telepresence. Like wherever you are, you can operate. If you're at office, if you're in abroad, or if you're in any area, any place in the world, you can operate from where you are. This is the flexibility, or this is the growth of an IoT, and this is an expansion we have seen as far of now. Okay. See, this is also some small example for enabling technologies in IoT. Like as we have said, like RFID, right? The radio frequency identification. How this transmission is happening. This is a small example. Okay. See, reader, transceiver controlled by a microprocessor and used to gather information from RFID tag. Radio waves are used to transfer data from tag to the reader. This is what the job of this reader. Now, if you can see, the connection is between a device like data and a reader antenna. In between, there is a reader, right? Now, this reader antenna will take the signals from the devices or any objects and like that. So, reading that through an antenna, transferring that data through reader to the database. Database here is a system able to get all the data related to the identification code. So whatever the data that is received from the reader through an antenna, all the data is stored in the database. This is a single thing. Next part. And what exactly a tag is? Radio frequency transporter composed by an antenna and a chip which stores the identification code. Now this tag, in this tag, we will be having code, identification code. It stores the information of the transporter. So this is what the processor they have followed, like in 2000, like radio frequency identification. Okay. So we'll move on to the examples. We'll see the real-time examples how exactly this IoT is working. Okay. In terms of application domains, there are IoT in IoT is an attractive in different applications. Yes, for instance, manufacturing businesses, okay, healthcare, retail, security, and so on. So among all these, it is essential that most of the market share with the IoT goes with the manufacturing and business sector. So approximately 40.2%, okay, approximately 40.2% approximately the growth of this manufacturing and business sector is happening with the support of this IoT. Okay, next if we can relate healthcare, retail sectors and security, surveillance, safety surveillance and so on with the help of IoT based systems. Okay, so if we talk about business or manufacturing, real-time analytics of system, like say real-time analytics of supply chains and equipment, robotic machinery, and the next thing is healthcare, portable health monitoring, electronic record keeping, pharmaceutical safeguards, and then retail, security, all these comes under this. When we talk about this business and manufacturing, we are talking about how to improve the overall supply chain. What are the different equipment that have to be introduced, and different sensors and actuators can be fitted to them. The different robotic machinery can be used in order to improve the business processes. The second thing is healthcare. Right? We can we are talking about a portable healthcare monitoring. Okay, telemedicine in much more better way. Okay, that means much remote areas can also be connected in different healthcare facilities, hospitals, nursing homes, doctors, nurses, irrespective of where they are. They can still monitor the healthcare condition, the health condition of the patients that they are treating. Then coming on to this next portable health monitoring, as we have seen, right? So in many of the cases, like hospitals, nursing homes, doctors, nurses, irrespective of anywhere and anywhere, they can use this IoT. Okay, these are some real-time examples where you can relate and understand what exactly an IoT is. By this, we have completed the introduction part of this IoT. And in my next lecture, I'm going to talk about the next topic, sensors and actuators. Okay, thank you for now.